Hi, good morning. This is another problem from brake, drum and shoe topic. It is given GATE 2019 in mechanical engineering paper. The problem is the schematic of an external drum rotating clockwise engaging with a short shoe is shown in the figure. The shoe is mounted at point Y. Shoe is mounted at point Y on rigid lever XYZ, hinged at point X. A force F 100 newtons is applied at free end of the lever as shown. Given that the coefficient of friction between the shoe and drum is 0.3. The braking torque applied on the drum is, all dimensions are in mm. So this is the same problem which we have solved in last YouTube. There the lever is straight one. Here the lever is configured unsymmetrical shape. This unsymmetrical shape, though it is in unsymmetrical shape, it is rigid one. It cannot deform. It will be always in the shape, in the same shape when you apply the forces. To solve this problem, we have to know the braking torque. What is braking torque? The braking torque is created by the friction force. This friction force related to this shoe, this is the shoe, friction force related to this shoe is in this direction. The same friction force related to this wheel rotation, it is in this direction. Now when you are considering the moments for the free body diagram of this lever, then the friction force is in this direction, that is small f. So that friction force into this radius gives the braking torque, that is product of friction force and this radius of rotation gives the braking torque. So to find the friction force, what you need, we need the reaction force. This reaction force can be evaluated from the equilibrium conditions. So take the free body diagram of this lever, identify the forces. One is applied force F at Z point. This is reaction force created by the drum on the shoe, that is R, and the friction force between drum and shoe is in this direction, small f. So these three forces will create moments at hinged point X. So take the moments about hinged point X. So when you take the moments about hinged point X, F into this distance create the clockwise, anti-clockwise moment. This product of this force and this distance from hinged point gives the anti-clockwise moment. This force, reaction force R into this distance create the clockwise moment at X point, and this friction force F and this distance 300 mm will create the anti-clockwise moment. Sum all the moments for equilibrium condition of the lever. The equation will appear like this. So negative means this is clockwise, anti-clockwise moment, F into 300, this F into 300, and R into 200, this R into 200 clockwise moment like this, and this friction force into this 300 gives the again clockwise moment. Sum of this equal to 0. Suppose this, substitute the value of 100 here and substitute the mu value 0.3 and we will get like this, and pull this value this side 100 into 300, that is equal to R 200 minus R 90. So subtract these two, will get 110. R is equivalent to something, then R is equivalent to 100 into 300 by 110. So we will get 272.72 newtons. That is R value. Substitute the R value in friction force F is equivalent to 0.3 into 272, that is 81.8. Substitute the value here F is 81.82 into this radius of rotation of drum, radius of the drum, that is R, that is in meters, 0.1 meters. So that is 81.81 is the friction force into 0.1, use the 8.18 Newton meter. This is the simple problem given for maximum marks. That's all. Thank you.